before. Too many people have written too much code that relies on the way we currently do things. It's almost an opportunity now that the Google Wave product doesn't need to, you don't need to worry. It's difficult for us to make changes because the Google Wave product is huge, and making changes is a lot of work. But without you guys having to worry about that, there's an opportunity to make the kind of changes that Christian was talking about. But you know, some people have already written a lot of code that works with Wave as it is now, and I guess it's a discussion that we all have to have. Can you guys hear me okay? I know my voice is not as strong as it might have been on Monday. Can you hear me up the back? A bit more, sure. I like holding it. So I'm going to give a short overview of a client-server protocol for Wave. I think this is lots of people have sort of asked about client-server protocols. People want to implement their own Wave clients on phones and other devices. And so I'm going to talk about a client-server protocol for Wave. It's not the one that's currently implemented, and I don't think we should stick with the one that's currently implemented, partly because it's not fully implemented because it was too tricky. But this is based on a design I sent out to the list a few weeks ago, and there's a few bits of discussion at the end. And of course, stick your hand up if you have questions at any point while I'm talking. Okay, so a client-server protocol. The motivation is a protocol that allows users to interact live with Waves, human users to interact live with Waves, so they can type and see other people's typing live, make formatting changes, generally mutate the conversation. So this is a live protocol. The data API provides a non-live protocol, which means it doesn't sort of receive live operations. You get snapshots of Waves, and I think that's probably the way we intend to leave it. There was a question a while, maybe on Monday, about whether we're going to add live stuff to the data API. I think the answer is probably no. It would just turn into another thing like the client-server protocol if we did that. So I think we should have the client-server protocol for live and the data API for not live. And being not live means you can be much more lightweight. This protocol is quite heavyweight to implement in a client. Okay, so I'm only talking about the wavy bit of the protocol, the bit that interacts live with Waves. There's obviously other bits that some client will need to be fully functional. Things like authentication, which is just assumed here, interacting with search, with contact lists, that kind of stuff. Much of that would be very much more system dependent, not something that we could standardize on so much. It would depend a lot on which backends we're talking to, which front ends. Yeah, so I'm not going to talk about those protocols yet. Perhaps they are something we can agree on later on. So for history, the Wave in a Box currently, and Google Wave, if you've gone and reverse engineered our over-the-wire JSON, implements a protocol that presents a view of a wave multiplexed over a single connection. So when you open a wave, you get a bunch of snapshots down the wire, one per wavelet. Then you get a marker that says that's it for snapshots, although it doesn't really mean too much. And then for each wavelet that is open, you can then receive deltas, and so you just tell which wavelet they are from the wavelet ID associated with the delta. And then you could submit deltas back to those wavelets. And your view has a channel ID, and so when you submit a delta, you say it's associated with this view. And then as a service to you, the front end that you're talking to drops your own deltas from the view, so you don't see them echoed back to you. So this was all multiplexed over one connection. The tricky bits are all come to do when we reconnect. So if your browser connection drops out, you go offline, something like that. We tried to have a seamless reconnection when you come back online. The browser channels and so on are relatively flaky. They seem to sort of drop out even on wide connections periodically. But we didn't want that to sort of affect your data. So when you reconnect, you used to come back with a big list of known versions of wavelets. You said, look, I saw this wavelet at version N, and it had this particular distinction or hash at the time. And then when you reconnect, the server will do a bunch of work to try and find a synchronization point and then restart everything at that point. So lots of those ideas are carried over in the new protocol. We just don't try to do it all over one connection. That made it very complex on the server side and sort of inhibits scalability and so on. So a client has these sort of 4 main requirements. They need to discover what wavelets are in a wave. If some search says, hey, you have wave X in your inbox, they need to discover what wavelets are in that wave and be able to fetch the current state of them. And then for each of those wavelets, they need to be able to stream live deltas and submit deltas again live. We break this sort of protocol into 4 services that the server provides, and the client can sort of use them in any order, although there's an obvious order that makes sense for a simple web client use case. So fetching is the first thing that a client can do. So the client comes with a wave ID and says, give me the wavelets in this wave ID, and the server responds with a list of snapshots of those wavelets at the current version, the latest version the server knows. And then to support reconnection, the client can provide a list of known wavelet versions, saying, I know that this wavelet is in the wave, and I last saw it at version 10, say. If you've got the wave and version 10 is the latest version, I don't need another snapshot. I've already got it. So if you've been working with a wave live and your connection drops out, you still have local state. If that local state is still valid, we don't need to send you a new snapshot over the wire. So that's what these known wavelet versions are. But if the wavelet has sort of moved on since that point, then we'll send you a new snapshot. Okay, so that's the fetch part. Oh, and then anyway, so all of this, by the way, is I'm presenting this as a protocol that's sort of transport agnostic. I'm not showing you which bits go over the wire. This is the kind of protocol that goes over the WebSocket or the socket.io library. You could put it over some other browser channel, something else, some other message-based connected channel.
That's a great question.
Yep.
Multiple wavelets inside a wave was sort of planned. What going forward is the reason to have multiple wavelets within a wave?
So we have 2 big use cases for them that are still pretty valid. One is the per user data that we store in a wave. So that's a wavelet that's private to each user who's viewing a wave. So an alternative to that is to store that in some non-wave data store somewhere. But using Wave benefits from reuse of this client-server protocol, the reconnection, the seamless synchronization, and so on. The other is private replies, and that was kind of the first use case that drove separate wavelets. So a private reply is a wavelet with a different participant list, and so your view might include some private replies. Yep, I don't think so the protocol right now doesn't, but yes, there's nothing fundamental. It's just a matter of coding, some more coding for it to support private replies.
You went down the route of providing a different structure to semi-structured data. Would that user data stored in a wavelet not be stored in a wavelet? Be stored in something else? Would it go away?
I think it would still be stored in a wavelet. It just wouldn't be a wavelet that was made of documents. We'd have some other type of thing that you could have in a wavelet, which was maybe a native map, an OT map or something like that. Okay, so this is a call and response fetch. It's a one-off. So there's one weakness in this protocol at the moment, and I'm sort of first describing a simple protocol, and then I'll talk about a couple of things that we can extend to make it better. So this fetch is just a call and response, and that means that if a new wavelet shows up in the wave at some point while you're viewing it, you won't find out about it until you do another request. But later on, we can extend this to provide a streaming view of snapshots, and then new wavelets, like a private reply, will show up live. So then per wavelet, we have a delta channel. So this is the channel upon which the client receives the live deltas. So the request to open a wavelet channel is simply the wavelet name, wavelet ID, and then a hashed version at which to begin the channel. So if you've received a snapshot from your fetch, your snapshot might be at version 20. Then you want to open the delta channel at version 20. So the first delta you get down the channel applies at version 20. So then the server will sort of scan back through the deltas it's already received. It must be at least at that version for it to have sent you that snapshot, and resend you anything to help you get up to date, and then be streaming live. So this is what we call a streaming RPC. So it has one request and then multiple responses. So the first response is a channel ID, which is used to identify the channel for later on when we're submitting deltas. serving a similar purpose to the current view protocol. And then future responses are either a delta and or a commit notice. So the delta comes down with all the kind of, it's a bunch of ops and then a bunch of metadata about the delta, like the version it's applying at, which you can check is your current version, the author, the timestamp it reached the server, and so on. A commit notice is piggybacked on top of this response, and that says that some wavelet or bunch of wavelets, or I think it might be one wavelet at a time, has been persisted to disk. So you might be aware that the Wave server, as deltas are received and transformed and applied, sorry, I missed Soren's talk yesterday, this was probably mentioned, it doesn't write them to disk straight away. Did you go over this? Yeah. So when they do eventually get written to disk, this message comes down the client-server protocol to let the client know that if it's holding any state, just so that it can do a reconnection at some point, this particular version has hit disk and you can drop any state before that version. You can always fetch it again from the server. Okay, so you get one delta. The client will open one delta channel per wavelet. Then for submitting deltas, the client must submit a delta against a known server version. So a known server version is a version the client knows the server saw. So if you receive a delta down the delta channel and you don't have any kind of outstanding submits against the server, then the delta you receive gives you a known server version. Or if you receive a snapshot, then that's a known server version. So if you imagine there's multiple clients all submitting deltas to the server at the same time, then the server gets them in some order. But any individual client doesn't know what order they reach the server and doesn't know which order its own deltas are interleaved with those until it receives things back down the wire from the server. So mainly this prevents the client, the main effect of this is it prevents the client from submitting two deltas at a time before receiving an acknowledgement of the first one. And this, we have this constraint. This gives us two great advantages. One is that it massively reduces the resources required by the Wave server to do OT. If you could submit arbitrarily many deltas at a time before waiting for acknowledgement, the server would need an in-memory representation per client of the whole wave in order for it to be able to make sense of your second delta after your first one. But if there's only one at a time, then the server only needs one in-memory representation. And so that's what we mean by known server version. It's a state of the wavelet that the server definitely saw. The other is that it auto-throttles the client-server protocol as you're buffering up local typing changes, waiting for your acknowledgement. So submitting deltas, you send the wavelet ID that the delta applies to, the channel ID that you got from the open delta channel's first message, and then the actual delta itself. And in response, I've left all the error responses out. All of these have a failure response, but in the successful case, you get the count of ops applied, which should match with the current OT, that should always match the number of ops that were in the delta that you sent. The hashed version of the wavelet after your delta applied, and the timestamp at which it applied. Okay, now...
Does that imply that if you have two clients submitting deltas on the same wavelet,
Yep.
different latencies, for each of the clients, the client can submit the delta against an earlier version than the version that's actually the snapshot version that's held by the server?
In theory, it can. Yes, a client can submit against, attempt to submit against an arbitrarily old version, and it's the server's job to transform it up past the entire history. In practice, we intend to limit the client's ability to do that. It's a big workload on the server. It's a denial of service opportunity. So in practice, the Wave server may reject your delta if it was too old, and tell you, the client, to do the job of transforming it up to the current version and try again. So what was some stuff I missed out? So, all right. So as a service to you again, when you submit on your delta channel, the server will emit deltas that it knows are yours. So if you send a bunch of deltas and some other client sends a bunch of deltas, you don't need to receive your own deltas back because you know what they look like. The acknowledgement that gives you this version here tells you when they applied, so how they were interleaved with other clients' deltas. And so the concurrency control object inside the client stack can insert the right can do transform at just the right point, and then once yours has been once the deltas coming down the stream catch up with the hashed version from your acknowledgement, you no longer need to transform past that client delta. Question? Yes.
Yeah, I have a question about the count of ops applied.
Yep.
Going back in the response, it seems like in practice it's either 0 or the number within the delta.
Yep.
Is there any intent there that it would be less than the number within the delta?
So it's possible for operations to transform away completely. Let me think.
I was thinking more in the case of like if one of those operations is actually rejected by the server.
Sorry, the server will accept or reject the delta in its entirety.
Okay.
So if anything fails to apply from a delta, the whole thing will be rejected.
Zero.
Yeah. It is possible for ops to transform into nothing, and so it was our intention that this meant you could have fewer ops applied than the number that you sent. In practice, we didn't finish the coding to have the client appropriately handle that case, and so currently if an op transforms to nothing, we leave a no op in there, which increments the version number but has no effect. So I guess in future the count could be smaller than the number of ops that you sent, but currently that never happens.
I was wondering, so if you get the response back with an error response, then you know the ops applied successfully.
Yep.
I was just mentioning writing a client, and I'm not really sure what I'd do with that number. I'd probably just throw it out. Did it really? Seems like you get rid of it out of the protocol.
Well, so getting rid of it would mean removing the possibility of ops transforming to nothing, and I guess we just haven't made that call yet.
What can you do with that information?
So the concurrency control object inside the the client's stack is keeping track of the version number of various things, like where the outgoing op was intended to apply, where it ends up applying, and where we're up to in the incoming delta stream. And so that version number is a count of ops, and so it needs to know if deltas are going to start coming down the stream with a number that doesn't line up to where we think a delta boundary is. It's going to freak out. So it needs to know where the delta boundaries are. How many ops were in each delta. Probably the best, probably an appropriate case will just be to drop that number, and but that will be giving up on the transforming of ops away to nothing. I'm not sure. That's something to think about. Okay, so all right, let's move on. A couple of other things. So wavelet creation, the design I posted a few weeks ago had a wavelet creation call. That's not what Google Wave does, and I've sort of flip-flopped back to thinking we should get rid of the explicit wavelet creation again. So wavelet creation then becomes implicit. You just submit a delta at version 0, and whoever gets the first delta in on a wavelet owns it. This has a couple of downsides. One is that we need a bunch of policing of deltas in the server. So certain wavelets are sort of have well-known names, at least in our current protocols. So for example, your user data wavelet has a well-known wave. Your client knows how to create it and knows where to expect it to store your per user red state. And so your client expects to be able to create this wave if it doesn't exist. So therefore, the server mustn't let any other client create that wavelet maliciously or accidentally on your behalf, because then you wouldn't be a participant on it and you couldn't store any per user data. So there's a few other cases. It requires this kind of policing inside a server, which would otherwise, of course, be policing logic inside a create wavelet call. But it's right in the depths of delta transmission. But in any case, implicit delta creation has many benefits. Of course, it makes it very obvious that the state of a wavelet is entirely defined by the deltas that apply to it. If there was some delta creation call, then that would have some effect on the state of a wavelet that would not be reflected in just the history of deltas. So that's the main reason that I think the implicit way is the way to go. Add remove participant. This was not. I haven't really addressed this in the design that I published. It currently just when you get removed from a wavelet, then the delta stream stops sending you messages. We intend to add a removed message to that delta stream. so that you can tell when you've been removed. You don't always get a remove participant op when you get removed. It may be that you are part of some group when groups are implemented in Wave in a Box. You may have indirect access to a Wave, say by being a member of the Wave protocol group or something. And if you get removed from the group in whatever system is implementing that group, then you lose access to the wavelet, but you won't see a remove participant op telling you that. So we need a remove message to tell you that you can expect to receive no more deltas on this stream. And then we need to improve the fetch service. So an extension to the fetch service is to be able to ask for older versions of the snapshot than the current one. And our intent is that if you've seen a version of a wavelet, you can always go and request that version again. We don't, we never take data away from you that you've seen. Unlike what happens? I think in docs, when you delete a doc, you can, it's gone. You can delete it for everyone. We didn't want that to happen in Wave, particularly, it's in Federation. It doesn't really make sense to be able to delete something for everyone. So the server should be able to provide you access with the last version that you saw. And so inside your user data wavelet somewhere, we stash the last version of the wavelet that you saw whenever you open it up in your client. And the fetch servlet should be able to answer a request for an older version of a wavelet. Now that imposes some load on the server to be able to answer that, and we haven't implemented it yet. But at some point, we should be able to, when you do a fetch across a whole wave, get the latest snapshots that you were able to see, and if you open a stream, be able to open a stream up to the point where you get removed. That's it. Hopefully that's been short and we've caught back up with time. Any more questions about client-server protocol? So again, this is sort of a transport-agnostic client-server protocol for interacting with live waves. It's probably something that we can standardize on, modulo some details so that everyone's clients can talk to everyone's servers in this way. It's ignoring some aspects of it, like authentication and sort of the non-wavy bits of the protocol. But otherwise, it's something I hope to be implementing in the next month or so inside Wave in a Box so that we can make sure it all works.
The participant list maintained using OT transforms? Is it basically just straightforward OT data?
Yeah, the participant list, I guess, is an example of us not using document operations to do OT, so it has its own OT, which is fairly simple. Anthony?
Do you still have to specify the inversion when you request history? Because when I was doing persistence, what happened was in open requesting, you had to specify the inversion, but the client only had the inversion from what they saw last, because if you're not online, your per user object wasn't created, and so it wasn't updated the last version you saw. So basically, I came home, and the clients, there could have been changes while they were offline, the server was included.
Yeah.
You just didn't get the, you had to actually make a change before you got all the history. And so I asked back then, I can't remember the answer was, why you had to specify this version as opposed to saying, just give me everything from this version when you do an open request.
Are you talking about the client server protocol?
Yeah, client server, client front-end import, basically, when you do an open request, you have to specify the version.
It doesn't ring a bell to me.
History request federation version, but the open request, even the old non-WebSockets protocol, you didn't have an end version specified. You did an open, you specify a wavelet, and then you just got everything.
I was pretty sure the first request when you did the open wave back in index wave, I think you
just download the code.
Let's talk about it during the break. That's a bit odd to me. Oh, that must be Dan.
Good morning.
Oh, that was Dan. Yeah.
Federation
Yeah.
protocol history requests require an end version, which I don't think we
Okay, sorry, any other questions? Otherwise, is it break time or is there another talk?
We got discussion on wave.
Oh, yes, an update on the Wave governance things. Right, excellent.
The index wave's gone away.
Oh, not yet, but I'm really trying hard to make them go away. Dan,